Running a modern supply chain is like navigating a vehicle at 100 miles per hour while looking only in the rearview mirror. You have a perfect record of where you were a mile ago, but you are effectively blind to the road immediately in front of you. This physical network is vast, moving trillions of dollars of goods through an incredibly dense, overlapping system of container stacks, distribution hubs, and highways. But this scale hides a structural fragility. The traditional just-in-time model is easily broken by labor shortages, severe weather, or sudden shifts in geopolitics that turn international border crossings into multi-day bottlenecks. Most companies rely on descriptive analytics, spreadsheets, and phone calls that only confirm a failure has happened. By the time an alert reaches a manager, the delivery window is already missed and the financial loss is locked in. In this environment, logistics can no longer function as a reactive cost center. To capture the $1.3 to $2 trillion in annual value lost to these inefficiencies, supply chain management must become the primary engine of business survival. The 2026 operational standard changes the objective. Success is no longer measured by tracking where an asset was yesterday, but by predicting exactly where it will be tomorrow. This requires building an anti-fragile system, a network designed to improve and adapt as it encounters stress, rather than simply trying to withstand it. To reach this state, enterprises are deploying a new technology stack that connects massive IoT sensor networks directly to artificial intelligence. This transition from passive observation to active intervention defines the start of the autonomous era. The core of this stack is agentic AI. While traditional tools only flag problems for humans to solve, agentic AI can reason through logic chains, access disparate enterprise systems, and take independent action to resolve disruptions. Consider a mid-transit shipping container. Among millions of incoming data points, a single IoT sensor detects a 2-degree temperature deviation. This digital twin replica ingests temperature data, instantly simulating scenarios and calculating spoilage in 8 hours. Agentic AI immediately identifies the optimal reroute, directing cargo to a closer hub. This collapses decision latency from days to a fraction of a second. A catastrophic loss of cargo is turned into a managed, predictable operation before a human is even aware the temperature deviated. Digital intelligence in the cloud translates into physical movement through autonomous freight on the ground. Autonomous trucks are now operating commercially on major highway corridors. By running continuously without the need for human rest breaks, these fleets are driving a 15 to 20% reduction in transportation costs. Inside the warehouse, the focus is on the inbound side. Autonomous mobile robots use computer vision and LiDAR to navigate dynamically, handling the sorting and depalletizing that once caused manual bottlenecks. This chart displays the direct impact of these systems. AMRs operate at 3 to 5 times human speed, while contributing to a 30 to 40% reduction in operating costs. Pairing agentic AI with physical robotics creates a self-optimizing economic engine. This allows a company to multiply its total throughput and handle higher volumes without a corresponding increase in overhead. The logistics industry faces a structural labor shortage that human recruitment alone cannot solve. Autonomous systems fill this gap by handling the repetitive manual tasks that would otherwise bottleneck the entire network. This shifts the role of the warehouse worker into a highly skilled fleet manager. These professionals now provide strategic oversight for robotic swarms, focusing on data quality and scenario planning rather than heavy lifting. This intelligence is also driving geopatriation. As global trade routes become more volatile, companies are using AI to rewire their networks toward localized hubs that are easier to secure and verify. Carbon tracking and sustainability mandates are now natively embedded into the AI's autonomous routing logic, ensuring every delivery path is optimized for both speed and environmental compliance. By elevating the workforce and localizing physical networks, the modern supply chain achieves the resilience necessary to thrive in a volatile economy. This graph illustrates the current divide. Early adopters who have integrated this unified data and robotics stack are achieving 30% efficiency gains across their critical metrics. As this gap widens, the most profitable companies are those commanding intelligent, autonomous robotic ecosystems. They are capturing quadrillion-dollar value that legacy operators are losing to delay and waste. In the era of autonomous logistics, the speed at which a company senses and reacts to disruption is no longer a metric,
It is the primary indicator of its market dominance.